Module 2. Section 3. Part 2. Basic server in Python using socket library. Before starting off, let's learn what a server actually is. In layman terms, a server is a continuously operational computer program that provides a list of services and functionalities to another computer program. For example, a web browser connects to a web server using a URL like www.yahoo.com. The task of the web server is to send requested web pages back to the browser. Let's begin constructing a simple server using socket library in Python. Create a new Python file. Start off by importing socket library. Next, we create a socket object and assign it to variable s. A server program does not request a connection, but a client does. A server needs to have a definite port number so as to which a client or multiple clients may connect. So, port 4444 is reserved and stored in variable p. Now bind function is needed to be called. A server has a bind method which binds it to a specific IP and port so that it can listen to incoming requests on that IP and port. A server has a listen method which puts the server into listen mode. This allows the server to listen to incoming connections. Passing an empty string means that the server can listen to incoming connections from other computers as well. If we would have passed 127.0.0.1, then it would have listened to only those calls made within the local computer. After that, we put the server into listen mode. Five here means that 5 connections are kept waiting if the server is busy, and if a sixth socket tries to connect, then the connection is refused by the program. At last we make a while loop and start to accept all incoming connections and close those connections after a connection alert message is sent to all connected sockets. Please note the server, even if is in the while loop, will not behave as a concurrent server, as the send will keep the server in waiting state until the bytes are received by the connecting program. To make it concurrent in nature to handle multiple connections, we can use threads, which we will learn to use later. Let's check whether the program is working properly or not. For doing so, I am going to use two command line utilities present in a standard Linux operating system, or can be easily downloaded as well. The first tool is named netstat. If you are unfamiliar with the tool, you need not worry. It will be covered in later modules. For the time being, in the terminal window, type netstat-antp, where A stands for all sockets, N helps not resolve host names, rather displays IP and port number, T stands for TCP connections, and P displays process ID and name. After running the command, we can clearly see there are three processes running on our system. Let's run the program. In my case, the program should start listening at port 4444. After running the program, we rerun the netstat command in a different window. This time the results are a bit different. There are four processes running. The second process in the list displayed is our Python server program, which is correctly running on port number 4444 and IP address 0000. The second tool which I was talking about is Netcat. Netcat is a small utility tool which can act both as a client and server. Let's connect to the server program as a client using Netcat. For doing so, run the command nc-nv with IP address as the loopback address, and port number as 4444. The server sends back the message as mentioned in the program.